Nuclear fission is a process that takes place, for example, in fuel elements of nuclear power plants. Such fuel elements are often several meters long and consist of several very thin fuel rods. In order to allow nuclear fission to proceed in a controlled manner, control rods exist. The control rods can be moved up and down via a motor. Fuel rods are hollow tubes that contain pellets, which are necessary for nuclear fission. After enrichment, the pellets consist of about 5% uranium-235 and 95% of uranium-238. Uranium-235 is an isotope of uranium and consists of 92 protons and 143 neutrons. A very important point is the fact that it divides into two lighter atomic nuclei as soon as another neutron is added to it. In addition, 2 to 3 neutrons and heat are generated, which can later be used to generate electricity. As soon as some uranium nuclei have been split, the neutrons, which have been released, trigger a chain reaction. They hit the uranium-235 atoms and split them. This results in the release of 2 to 3 neutrons, again and again. This process can be illustrated mechanically with a domino effect. An event, for example the impact of a ball, is the trigger for a chain reaction. Each individual domino is the cause and effect at the same time. In addition, all of these events are based on a single initial event. Nuclear fission chain reactions in a nuclear power plant can only be maintained under certain conditions. On the one hand, certain isotopes are usually required, such as the uranium isotope U-235, and on the other hand, a moderator, for example water, is required to slow down the neutrons. Without a moderator, the self-sustaining chain reaction in a nuclear power plant cannot be maintained, since the neutrons are too fast and thus the probability of nuclear fission decreases. A chain reaction would be impossible. The control rods of a pressurized water reactor can be moved down to stop or slow down the chain reaction. They are composed of chemical elements, such as boron, silver, indium, and cadmium. These absorb some of the neutrons that are released, so that they can no longer contribute to the chain reaction. Nuclear fission of uranium-235 produces various radioactive fission products that are fatal to humans.